Now we're going to go a slightly different way. We're given a triple integral and we're asked to sketch the solid whose volume is given by the triple integral. The integral is from 0 to 2 of the integral from 0 to 2y of the integral from 0 to 4 minus y squared dx dz dy. Looking at the order of integration, what we can see is that x goes from 0 to 4 minus y squared. Z goes from 0 to 2 minus y. Y goes from 0 to 2. We're going to attempt to approach this by going straight to R3. Sometimes it's useful to stop off at R2. All right. In the xy plane, we're looking at the curve x equals 4 minus y squared. That all of the variables have a lowered limit of 0 means that we are in the first octant. X equals 4 minus y squared is a parabola that opens along the x-axis. It's oriented sideways. You know what? I guess we'll go to R2. In R2, since the y squared term has a negative coefficient in front of it, we know that this opens in the negative x direction. And because it's 4 minus y squared, it's going to be located with its vertex 4 units in the positive x direction. If ever you struggle with something like that, think about what you would do if it was y equals 4 minus x squared, and then translate that into the orientation that we're given. So this parabola here looks like that, something like that. And it has its vertex, like I said, at 4 units out on the x-axis. And then it has y-intercepts at 0, 2 and 0, negative 2. We are only concerned with the portion of it that is where x is positive and y is positive. That in the xy plane in R3 is going to, be the same, right? It's got its vertex 4 units out on the x-axis. I wasn't convinced, so I drew it a few more times. So 4 there, and then 2 units on the y-axis for the y-intercept. And that will agree with y going from 0 to 2, so we're good there. Now I'm looking at the inequality involving z. Z goes from 0 to 2 minus y. So now I'm thinking about that z is equal to 2 minus y. Well, let's go into that R2 as well. In the yz plane, that's a line that has a y-intercept of 0, 2 and a slope of negative 1. Did I say y-intercept? I mean z-intercept. A z-intercept of 0, 2, a y-intercept of 2, 0, a slope of negative 1. But we know that in R3 that's going to translate to a plane. So 2 units up on the z-axis, down here, intersecting the y-axis 2 units out. That forms one boundary of the region. Now back to x equals 4 minus y squared. That is a parabolic cylinder. It's a sheet that goes straight up, but it's being sliced at an angle by this plane. So let's see if we can visualize a little more of the plane. And then I'll draw a vertical out here just to give us the vertical face of this thing. Now, I didn't draw this edge of the plane here because we have this parabolic cylinder. So what's going to happen is, envisioning what happens to a parabola when it gets sliced at an angle, we have this kind of wedge thing. It's got a flat face on top and then a vertical curved edge where the parabolic cylinder exists. And folks, that is our solid.